Well, it's me again. I am not Sarah Hughes, unfortunately. Just to give you sort of an update on who she is and the fact that she's not here. So Sarah is our incoming new faculty member in the fall. She will be the assistant professor of water policy, politics, and planning in SEAS. And her focus is on urban water. And we learned from Sarah yesterday morning that she was going to arrive in Michigan and arrive in Ann Arbor tonight, right around 5:15. So I said, hey, wouldn't you like to give a lightning talk? And I would even give you 6 minutes. So she said sure, and sent along her slides. But she's somewhere between Toronto and the Detroit airport, and she's about an hour missing. So not quite sure where she is. So she didn't quite make it, so we'll move along to our next speaker. And if she shows up at the end, we'll fit her in.
So if her slides in there?
Oh, good point.
Cycle through them.
I'm not going to give them.
Don't give them.
How's that?
Thanks. Hello, everybody. My name is Lutgarde Raskin, and in this slide here, I have tried to focus in on one of the two main areas that I do research in. I work on developing anaerobic biotechnologies to recover resources from waste streams. And we were asked to talk about the biggest challenge associated with our research. And so I'll just tell you that the biggest challenge with developing these technologies is that they're not economically feasible at this point. And so what we're trying to do is increase the yields of, for example, methane is one of the products that we're trying to produce, increase the yields of methane production from these waste streams so that we can make those technologies economically feasible, and that this is not just a cool technology that students want to work on, but we can actually implement this in practice. In addition to methane, as you can see, there's lots of other byproducts that we work on, and some of those are the ways that we deal with making these technologies more economically feasible, so producing other high-value products from these waste streams. The second area that I work on is thinking about how to change what we do in drinking water treatment to positively impact microbial water quality. So a lot of what we do in drinking water treatment to remove contaminants, chemical or microbial contaminants, has unintended consequences, and oftentimes we impact the water quality negatively by trying to do the right thing. And so those complexities is what we study in our work in the drinking water field. And so you can imagine that the biggest challenge there is to try to develop technologies that are sustainable and do the right thing without having those unintended consequences. So those are the two challenges that I deal with in my research primarily. All of my research not all, but much of my research can be framed within this urban water cycle. So most of you are very familiar, so I don't have to explain this in detail. But what you may not realize as much as we do is that microbiomes are really critically important throughout this urban water cycle, specifically complex microbial communities, where we have thousands of different microbial organisms that interact amongst themselves, but also with their physical and chemical environment. And so those interactions are what we take advantage of and study and try to get the best out of those microbiomes to treat our water and to deal with this urban water cycle the best we can. And so an area that I would like to push more in terms of these collaborative opportunities here is to interact with people who study microbiomes in natural water systems and with people who study microbiomes in humans. So the human microbiome, you hear a lot about this, but of course what we do in our urban water cycle and the microbiomes in our water impacts both the human microbiomes and are impacted by the microbiomes in the natural water systems. And so I've pushed this theme of these interacting microbiomes quite a bit, and we recently had an opportunity in the College of Engineering to write proposals for this Blue Sky initiative. And I've pulled together a team of people to push this message of how we can remake our water infrastructure by focusing on microbiomes and focusing on these inner linkages between microbiomes in our water systems and the natural environment and human systems. And we push this by focusing not just on the technical and scientific aspect, but also the actionable science and the interactions with stakeholders. These are the people from the College of Engineering who are involved in this effort, and these are people from across campus, and you can see that we have a couple people from SEAS involved in our larger team, Maria Lamas and Rebecca Harden. We're also engaging people from other universities. These are the people I'm working with at the moment. This is a smaller subgroup to get this effort started. So we're starting officially May 1st, and so I've mostly been working with the faculty that are in blue from the College of Engineering to get our effort off the ground, and then we'll re-engage the larger group once we move forward. This is a large effort that the college has put funding towards. It's not 10 million, it's 10 million divided by 4 because they funded 4 projects, but still, it's a large effort. And to kick off our effort, one of the things we're doing is engaging through Drinking Water Innovation Salon with stakeholders. So we're inviting utility personnel from across the state to engage with drinking water researchers. And then we'll follow up with them and kind of develop a research roadmap for drinking water through this initiative. We do further outreach every 3 years by organizing a conference where we get people from across Michigan and beyond to engage with us on these topics. I'm going to skip this slide. This is just giving you more details on what we are planning to do in our Blue Sky project. And I think this might be, no, I have a couple more slides, but I'm not going to tell you, I stuck those in. I told Paul if I have time, I don't. I put those in there to show you that we're also working, in this case, in Bangladesh, and there's people from SEAS, you see Arun Agarwal, involved in this, and we're developing a project in Gabon, Africa, and there's another SEAS faculty member down here, Rebecca Harden, who's engaged in this work. So I get pulled into different directions, but I told you about the main areas of my research. Thank you for your time.